Alright, so I'm going to make a short little video here to help you with today's diagram. Let's start out by analyzing the rubric. We could just start by getting through the first one um, and go through all four. The last one, you kind of need to analyze each four parts of your picture and I guess add some words and captions. So I don't want to do these each on separate pages. You'll probably be prevented from seeing like a pattern or big picture. So I'm going to pretend like this white space right here is your piece of paper that you'll be working with tomorrow. And let's break this up into quadrants. So you have to draw 2 lenses and 2 mirrors. So you don't have to organize your paper like this. You have 4 smaller boxes making up your paper, but it is one way you could do it. So we're going to have, let's say we'll do the lenses on this side, and then we'll do the mirrors on this side. So I think we already know what mirrors do. Since we see our reflection in a mirror, they reflect light, meaning there's no light transmitted. And what a lens does is it refracts light. So the light gets transmitted, but since some of the light, since the light is interacting with the glass particles, that's what a lens is. It's a curved piece of glass. Since the light is interacting with those particles, it slows down and changes its direction. And that's essentially what refraction is when light is transmitted through something and it gets refracted. So let me jump back here to the rubric. You need to show the process of light refracting through a lens that is thickest in the center. So before I draw the light interacting with that lens, let me just draw that. This right here, this type of lens that's thickest in the center. You could just draw it like the way that you saw it in the simulation where one side was flat and the other side was bubbling out. I'm going to draw both sides bubbling out on each end. So it just kind of looks like an, I don't know, an oval. It's curved on each end, and if I go through the center of the lens, that's the thickest part, whereas the top and the bottom are the thinnest parts of the lens. The next lens is the thinnest at the center, so I'm going to draw that one down here. This one gets curved inwards. We'll do it on both sides. So, a curved piece of glass, bends light that it goes through it, thinness in the center. This is a specific type of lens. I'm going to leave out that answer for you to find, but after yesterday's reading lesson, or reading notes, last week's simulation, and the pre-tests, hopefully as you're looking at this, the vocab word pops into your head automatically. Alright, so now we want to do the same thing with a mirror that curves outwards from its center. So it's just going to look exactly like this. This time though, I'm not going to do double-sided. I'm just going to do one side of the mirror is curving outwards from its center. I guess technically if the light rays was coming from this side, it would be curved inwards to its center. So maybe I should just make it double curved on both ends. And then the same thing with the mirror. A mirror that's curving inwards towards its center. So hopefully you're seeing that there's a pattern here. Thinnest in the center, curving in towards its center, curving out from its center, thickest in the center. You get pretty much the same shape whether you're dealing with a lens or a mirror. The specific name for each of those things Like I just told you, you're going to need to figure that out. But the way that they look, I don't mind giving that to you right now. So, the reason why I want to do this on one page is you got your mirrors over here, your lenses over here. You have lenses that look just like mirrors. They're thickest in the center or bubble outward. You have lenses that look like mirrors down here. They're curved inward and they're thinnest in the center. All right, so now we have our objects with either reflective or refractive materials, and we can see what it looks like when light passes through or bounces off each. So let's start with this one. When light refracts through this lens that's thickest at the center. So if I was to draw some beams of light, when they hit this type of lens, what happens is they get bent inwards, like so. So you're going to want to explain this in your caption, but there's also a technical vocabulary word that I want you to know. Now, if I had a light ray that was just passing right through the center of the lens like this, it wouldn't bend at all because it's hitting this lens in the one spot where it would be at a right angle. So this is like along the normal line right here, or the line that forms a right angle with the surface of this object. So this is 3 light rays. They're all hitting a curve. The top and the bottom are hitting a curved part, but they're coming together at this specific point right here. And you should already know what that point is called. Now, they would actually only pass through that point if they were traveling parallel to this dividing line between the center, but we don't need to get into those details right now. All right, so now let's do the one where the process of light refracting through the lens that's the thinnest at the center. So this type of lens, the light rays bend inward due to their change in speed. With this lens down here, they do the exact opposite. They don't bend inwards. Instead, they get bent outwards. Let me try to note the direction of these. So, if I have a parallel set line that's right smack in the center, it wouldn't bend at all. It's got to strike the surface at an angle in order for the refraction to occur. It's pretty hard for me to do. What you want to make sure, and I did a good job doing it over here, is that the bend is not continuous. It's a sharp bend, like it happens immediately. This one is pretty curved. You don't want to show the light rays being curved. Light will travel through a straight line. It's not going to travel through a curved path unless it's traveling through curved space, but we don't need to talk about that right now. Okay, so now over here, this is the third component of your rubric. When light reflects off of a mirror that curves out from its center. So it does not transmit. That's why I didn't leave myself much space over here. But it reflects. Now the way it reflects is almost the opposite of how it gets refracted through the mirror. It all has to do with the law of reflection. And it's very subtle about how the angles are different on this curved mirror right here. But one that is above this center line, well, let's talk about the center line first. If I have a light ray passing right through the center of this mirror, it's actually going to bounce back in the same direction that it came from. So this is the starting point, but when it hits it, it bounces back and it turns as the ending point as well. But anything above that line, it's going to be reflected upwards, and anything below that line, it's going to be reflected downwards. Now, before I move any further with this one, I want to talk a little bit more about this point right here, this focal point. So if I was to form an image of an object, so let's say all this light here is coming from an object right here. If I form the image of an object right here, due to where these light rays come together. Now these over here, you might think, oh, well, they don't come together, no image will be formed. Well, these form what's called a virtual image, where it looks like the light rays are coming from a point back here, from anybody who is observing the light rays coming through. So if I have an observer on this side right here, somebody's looking at these light rays, whatever object there is, it looks like it's right here rather than back here at the source. And if I have an observer over here, this is an eyeball, the object looks like it's right here, and it actually looks like it gets reversed, like it's upside down. And if you look at these light rays, the one that's on the bottom becomes the one that's on the top, and the one that's on the top becomes the one that's on the bottom. So my image over here would be reversed, and it would look like it's a lot closer, like it's on this side of the lens. And some people that wear glasses, that's why, is to change where the image that they're seeing, where it looks like it's located. That's how magnifying glasses work, how binoculars work, how telescopes work. But the distinction between where these light rays come together at a focal point or where the image appears as if it is from a different position. That's not that important for this assignment, but it's important enough to introduce right now so it's not super confusing in your next assignment. For instance, the focal point for this one, all I would have to do is follow these lines back, and it would look as if this image was right here. Wherever these lines appear to emerge from, that's what we call a virtual image. Whereas this right here, where they actually come together, that is where there is a real image being formed versus a virtual image being formed. Okay, last type of mirror. Oh, and then so the observer's over here on this side, looking as if something that's reflected is kind of like pushed back further in space. Okay, for real, last one. So here's my observer. Say there's light rays coming from this direction, hitting this mirror. Let me get rid of that. So these light rays do the exact opposite of what this type of mirror did. When they hit the surface, they reflect inwards. Now, if a line reflects off of the mirror, at the one point where it doesn't actually hit it, where it's curved, then it's going to bounce back along the same path that it came from. And then let me get one last line there. This one is going to reflect like this. And notice they're all coming together at a point, and this is where it looks like wherever this, the light came from, the source of this light, whether it was a bulb or just light that was reflected off something, to this observer right here, let's say this is a person, it's going to look like the object that this light's coming from is right here, and it's going to look inverted or upside down because these light rays swap positions. The one on the top turns into the one on the bottom. The one on the bottom turns into the one up top. So this would be an actual image, just like over here you get an actual image, whereas this creates a virtual image over here. So hopefully you're seeing some patterns here, how the light that reflects off of a mirror kind of looks like the light that refracts through a lens when they have the opposite type of shapes. And the same is true for here. The light that gets refracted by this type of lens looks exactly like the light, well, not exactly, but hopefully you see it gets spread out. There's a name for that you're going to have to include in your diagram. So let's jump to that last part, and this will be over real quick. So the lens or mirror types need to be labeled. Now there's really only two words that I'm looking for here, but I'm not going to give it to you. You need to tell me what type of lens this is, what type of lens this is. I'm not going to tell you the whole word, but I'll give you a hint. They both start with the word con. You need to fill in the blank. So whatever letters go here, it's your goal to not only figure out what that is now, but also make sure that you know it for the day of the quiz. All right, and then exact same thing over here. Whatever name that you have for this one, it's going to be the same for this one because it's describing the shape of the object that the light is interacting with. So whatever one that you found here, you're going to have to put that word here since these two have the same shapes. The main difference is that whatever the material they're made out of, the lens allows them to go through, whereas the mirror does not. So that's 9 out of 10. One last thing that we need to do is have captions explaining how the light rays are affected. Now, I already told you these ones refract because they allow it to pass through. These ones reflect because they don't. What I want you to tell me is how the direction of these rays change. So, when light rays pass through this type of lens, the rays do something, and it's about this behavior right here, how these light rays come together, this specific word. So I should see a sentence at the bottom of each one of these. It says light rays are, and then you need to fill in the blank. So there's really two words I'm looking for. I think this one I'll give you the last part of the word. So verged. Okay, you need to fill in the blank there. When the light rays are passing through this type of lens, they are something verged, and they create an actual upside down image. You don't need to say that, but it's worth understanding now so that Friday's easier. And then over here, same exact sentence. The light rays are, you need to fill in this blank. I'll tell you what the last 6 letters are, but you need to fill in the first 2 to 3. So, how are these light rays changed? They're spread out, but there's a technical vocabulary word that you need to learn. Now, over here, same exact thing. The light rays are, same thing over here. I'm not going to do all this for you. But notice, these two don't line up anymore. They might line up in their shapes, but the way that the light behaves, this one is much more similar to this one. If you look at all of these rays that were traveling parallel to each other, they are now getting further apart. This angle right here is making it so that they are not, or they're gradually over time, they're going to be spaced apart, greater from one another. And then over here, same thing. The light rays are, and they're not doing what this lens of shape does. These right here, they're coming together. They're forming an upside down image, whereas these two right here are forming a right side up virtual image. But I don't want you to talk about the image here. I want you to talk about, are they being this type, or yeah, this one is going to match up with this one here. So please try to make sure that your picture doesn't resemble mine identically. Like if there's 3 eyeballs and 1 eyeball with a face, it'll be obvious to me that all you try to do is just copy down everything that I did without thinking about it, and that is not going to prepare you for your test. So try to make it look good enough to hang up, and that would be appreciated. All right, I hope this helps. Have a good day.